Hi guys, welcome to Mindset Learn Extra Live. I'm Katleho, grade 11s, and we're here with Peter today. Peter, we're doing probability, are we?
We're doing probability, absolutely. And the great thing about it is that's like my most favorite part of the syllabus.
So we're really going to have a great time today.
I think we
Grade
are.
11s, I know you guys and your math literacy, you guys are on the ball. So today we're going to be active. So I'm glad you guys are here to join me today. Remember our Facebook page, facebook.com/learnextra, and our Twitter handle @learnextra. Hey,
Right,
you know it, right?
whatever that means. Yeah, go for it.
Okay, guys, make sure that you are ready for a fantastic show, and tell your little brothers and sisters to shh for a little while Peter's in the studio with us. Peter, over to you.
All right, Kat, it's great to be here. I've never worked with you before, so
Yeah.
this is a first, which is really great. So
Yeah, I'm
welcome to our
excited.
studios. It's really fantastic.
Thank
I love Thursday. I wake up every Thursday morning and say, it's time for a bit of mathematical literacy. And it's my favorite subject. I love it like you can't believe. And it's something to look forward to every single Thursday. So, welcome. And this Thursday was extra special because we're doing my favorite topic, and that is probability. And I think I like probability because you can play games with it, you can have fun with it, you can really do amazing things. Sadly, though, and this is really, really sad, in matric, it's one of the worst answered sections in the final paper. And you know what, I'm not 100% sure why. Because if you understand certain basics of probability, then it should come rather easily to you. So that what we're going to do today then is this. I've got a few questions and I'm just going to work through them. And while I work through them, I'm also going to do a little bit of teaching. Okay? So let's have a look at the first thing on our screen. Now, with probability, what we're going to look at, I'm not even going to read the question, I'm just looking at this fantastic graph at the bottom, where we've got something called impossible, I've got equally likely, and then I've got a certainty. All right? Now, what we need to understand, that probability can fit on a line scale. Okay, so if I gave you certain scenarios, you would say, well, let's see where they can fit on that line scale. Understanding that on the one side of the line scale, we have something that's totally impossible. It can never happen. It will never happen. Right? And on the other side, we have a certainty. It's going to happen. It has to happen. It can't happen any other way. That is a certainty. In the middle, we have a 50-50 chance. Okay? And we're going to give you examples of those just now and have a look at it. So when I look at probability, well, the first thing I want to say is this, that probability can be written in three different ways. Okay? We can write it in words. So we can say, hey, this is impossible. Or we can write it as a fraction. Or we can write it as a decimal fraction. Got that? Okay. So let's say, for example, I know there's a probability that something's going to happen, and we have a 1 in 10 chance of that happening. Okay? In words, I would write a 1 in 10 chance. As a fraction, I would write it as a 1 in 10 chance. As a decimal, we could write 0,1. Because if I looked at that, 1 divided by 10 will give me 0,1. So my scale now would, if I've got it in words, I've got impossible. Okay? I've got a certainty. And I've got a 50-50 chance or equal likely chance. In numerical values, impossible means there is no chance of that happening. Okay? For probability, when we look at numbers, we say if something has a 100% chance of happening, we're going to give it a 1. So any probability lies from 0 all the way through to 1. So a 50-50% chance of something happening is halfway between 0 and 1, which we could write as 0,5. Okay? And all probability lies between that 0 and that 1. All probability lies from impossible all the way through to certainty. So let's have a look at this. Now we're going back to our question. And our question is this. Consider each of the scenarios below and then place them accurately on the scale below shown in the example. Just write the letter on the scale and not the whole sentence. So, if we look at our first sentence says this: pigs will fly in the sky today. Now, folk, if we go outside and we look at the phenomenal view of wherever you live, all right, so here we are in Johannesburg. If I go outside and look at the wonderful polluted air out there and see all those buildings and everything else, there is no chance at all that I'm going to look up and see a pig flying from one building across to the other building. That's just never going to happen, okay? And no matter how many days in this month I go outside and I stand on the building and I look out, I'm never, ever, ever going to see a pig flying in the sky. It's not going to happen. It never happened when my great-great-great-great-great-grandfather was a little boy. And it's never going to happen when my great-great-great-great-great-grandson is a little boy either. It's never going to happen, okay? The chances of pigs flying are 0. Impossible. And so what I've got now is I've got A on this whole thing of impossible. Not going to happen. Now, what's a probability that you can run 100 meters in under 3 seconds? Well, for some people, running 100 meters under 30 seconds is impossible. I think of my producer. But in 3 seconds, if we think of 1, 2, 3, guys, that's never going to happen. We're never going to run 100 meters in 3 seconds. In fact, the world record is 9-point-something seconds. How are we going to do it in 3 seconds? Never going to happen. So where is it going to fit on my scale? It's going to fit on my scale exactly where the A is. So I'm going to take one of these B's. Let's take it, and we're going to put it right there by the A. It's not going to happen. Now, what's the probability that rain when the forecast says there's a 70% chance of rain? Well, if there's a 70% chance of rain, well, we've got a 70% chance it's going to rain. Okay. Now, one thing I want to clear up with you guys out there is this, that when I was much younger, okay, last week, what actually happened, I always used to believe that if we said 70% chance of rain, it meant 30% of the day it was going to be dry, and 70% of the day it was going to rain. Well, that's not really how it works, okay? But what they actually mean is, if they take this weather pattern and compare today's weather pattern with similar weather patterns before, and they look at 10 of those weather patterns, 7 of them, it rained, okay? So if we got the same weather pattern as we did in those 10 occasions, chances are, because it rained 7 times out of the 10, there's a 7 out of 10 chance it could rain today, right? 70% chance of rain. Now, where does that fit on my scale? Well, if we had to look at this as a percentage now, and we can also write probabilities as percentages, hey, from 0% through to 100%. So if we wrote 0% to 100%, we could agree that impossible means there's no chance of that happening. 0%. Certainty, there's a 100% chance of that actually happening. Okay, so what is in the middle? In the middle, we're going to say there's a 50% chance of something happening. Where's the halfway between 50 and 100? It's 75%, isn't it? 75%. Now, we are looking for 70%. So 70% is somewhere in this area just before the 75. So let's take one of these C's and let's move it. And we're going to say, well, it fits in somewhere over there. Got it? I like this board, hey, Kat.
Yeah,
you can
it's
just
very
take letters
cool.
and
Yeah,
throw
you
them
just
all
throw
over
them
the
around.
place.
That's awesome.
Fantastic. It's like
I
my
want
wife.
one of these at home.
It's like my wife. She just takes me and throws
And
me
throws you
around,
around.
okay? All right, D. What is the probability that a pregnant woman giving birth to a boy? Okay, well, let's think about this. All right. Now, what we are presuming is that there's no genes involved and all this kind of stuff, all right? You're either going to have a boy or you're going to have a girl, right? So it's like Mudley. Mudley walks down the road the other day and he walks into Naidu and he says, "Hey, Naidu, guess what? My wife, she had a baby yesterday." And Naidu says, "Yeah." He says, "Yeah, guess what it is?" He says, "A little boy." "Yeah." He says, "No, guess again." He says, "A little girl." "Yeah." He says, "Oh, no, who told you?" Okay, stupid little joke. Ridiculous. I'm glad you're laughing. You're the first person in the studio who laughs at my jokes.
I think it's funny. I think you're
Cool.
really funny.
All right. So if my wife is about to give birth, guys, there's only two things, all right, that are going to come out of it, or one of two things, rather, okay? Either a little boy or a little girl. Although nowadays anything can happen.
Yeah,
hey?
nowadays
But
it could be a merge
we'll
of
pretend we're talking about the good days, all right? So a little boy or a little girl, nothing else, guys. Okay? So if a woman's about to give birth, and I don't know her history, I don't know her family genes and all the rest, I'm going to say, you know what, there's a 50-50 chance that this little thing is going to be a boy, or this little thing is going to be a girl. So what's the probability of her giving birth to a boy? It's going to be a 50% chance. There it is. We're putting D on our 50%. Here's an interesting one. What's the probability that you'll draw an ace from the top of a pack of cards? Now, folk, if I were to give this question to my matrics and to my grade 11s, right? Because remember, grade 11, grade 12, there's a very thin line between the two grades. A lot of work you're doing now in grade 11, you'll see in grade 12. In fact, if you tune in next week to the grade 12 session, we're also doing probability. You might even see me go through some of this stuff again, because there's nothing to stop us from giving you this in a matric paper, as well as at the end of your grade 11 year. So what we're now going to do is we're going to look at what's the probability of getting an ace in a pack of cards. Now, if I were asking that question to my grade 11s or my grade 12s, I would tell them a little bit about a pack of cards, what it consists of, right? And I would say, do you know that there are 52 cards in a pack, excluding the jokers? We'll just pretend there's no jokers. So I got 52 cards in a pack. And in a pack of cards, I've got, Kat, how many aces?
4 aces.
4 aces, absolutely. You're quite the gambler, hey?
No.
No, not.
No,
All right.
no,
I was going to take you to
I
Monte Casino, but we won't do that. All right. So I've got 4 aces. So if I've got 4 aces and there are 52 cards in a pack, what is that as a percentage? Well, let's take up our calculator and let's do that. So we are going to say, right, I've got 4 over 52, and that's going to give me 1 over 13. Let's times it by 100 because we want to see it as a percentage. It's going to land up giving me 7.7%. All right? So 7.7%, right about 7%. Now, guys, 25% is going to be over there. Let's get a pen. 25% over here. Okay, half of that is round. I'm going to pretend zeros over here. Okay, we've drawn a big rectangle around the word impossible, but let's pretend zeros there. Okay, so 12.5% is over there. So the chance of drawing an ace from a pack of cards is 7%, and 7%, guys, is going to be round about over here somewhere. Okay, so we'll just put it over there. Do you see how this works? Okay, remembering that I have from impossible all the way through to a certainty. Now, I've brought along a dice into the studios, okay? And we all know what a little dice is. Is it a dice or is it a die?
One die.
One die,
No,
two
many
dice.
die.
Okay,
One
or one Yeah, I don't
Yeah,
know,
it doesn't
one mouse
matter.
and 2 mice. I don't know. Anyway, this is Maths Lit. This is good stuff, not English. It never makes sense,
Yeah.
does it? Okay, so I've got a dice. Let's call it a dice. Why? Because I want to, and it's my show. So we've got a dice here, and this dice has 6 sides to it. On every single side, there's a number. So I've got the number 1. Can I come forward? Here we go. So I've got the number 1, and then I've got a number 2 and a number 3. You all know what a dice looks like. I don't have to tell you. Right. So what I'm going to do now is I'm going to give this dice to Kat, and she's just going to roll it. Okay? When you get a 0, stop. Okay? But you keep going until you get a 0.
Okay.
You don't stop, and I'm going to ask that our producer every now and then, where is she? Oh, there she is. Our producer every now and then just focuses on you to make sure that you're still rolling the dice, trying to get the 0. Got it?
Let's do it.
Okay, so here's your dice.
I'm rolling it on the table.
You're rolling it on the table and you're having a lot of fun. While you're doing that, let's go on to our next question. So our next question is this. Right. Give the numerical value to the words impossible, equal likely, and a certainty. Okay, now we did speak about this earlier, and so we know what it is. How's the rolling going? Got a 0 yet?
Not yet.
Not yet, you just keep going. Okay, so impossible means 0. Okay, not gonna happen. Now it can be 0, it can be 0 over whatever, okay, I don't know, over 10, over 20, over 30, 0 over anything is 0. And it can be 0%. Equal likely, how's the dice rolling going?
Good.
Have we got a 0 yet?
Not yet.
Not?
yet.
Okay, great. So now, what is the terminology or numerical values for equal likely? Well, equal likely could mean I've got 0.5 chance of something happen. It could be 1 over 2, or it could be 2 over 4, or 3 over 6, or 5 over 10. And as a percentage, it's a 50% chance of something happening. How do we write a certainty? Well, a certainty is going to be 1. It's definitely going to happen. Remember, it ranges from 0 to 1. Or here, we're just going to carry on writing 1 again. And as a percentage, we're going to write 100% chance of that actually happening. Okay, Kat, I need to know, why are you not rolling a 0?
I think I got a 0. Wait, let me check. I think it's a 0.
No, there is no 0.
Okay, fine.
And the reason why Kat hasn't got a 0 is because there's no 0 on this dice. So if we say to Kat, look, would you mind, at the end of the show, we going home, you just keep rolling until you get to a 0.
I'll roll forever.
Kat would be here rolling and rolling and rolling and rolling and rolling the dice. We would come back next week, and she would be here somewhat trimmer because she hasn't had food, and rolling and rolling and rolling the dice. If she turned 85, she'd still be here rolling and rolling and rolling the dice. If our producer turned 85 in 3 years' time, she would still be rolling the dice, rolling the dice, rolling the dice. Okay? She would never, ever, ever get a 0. Why? There is no 0 on the dice. And because there's no 0 on the dice, it's impossible to roll it. If I said, however, Kat, roll this dice, and you've got to get a number, either 1, 2, 3, 4, 5, or 6, what's going to happen?
No, there's a 1 in 6 chance.
Well, I would say there's a 6 in 6
There's
chance.
a 6 in 6 chance.
Absolutely,
actually, yeah.
hey? Because you're going to get either a 1 or a 2 or a 3 or a 4 or a 5 or 6. Because there's only 1, 2, 3, 4, 5, 6. So what's the chances of getting a 0? Absolutely nothing. Impossible. What's the chance of rolling either a 1, a 2, a 3, a 4, or a 5, or a 6? 1. It's definitely going to happen. What's the chance of rolling an odd number? Well, what are my odd numbers? So I've got the numbers 1, 2, 3, 4, 5, and 6 on the dice. There's an odd, there's an odd, there's an odd. So I have 3 in 6 chances. Simplified, I have 1 in 2 chances, or 50% chance, or a 0.5% chance of rolling an odd number. Do you see how we're doing this? Okay. Do you understand the concept of absolutely no chance, a certainty and maybe a 50-50. If you understand that, guys, that's fantastic. You've really picked up quite a bit. And then after the break, we can take it a step further. Kat, over to you.
Yes, let's take a break, guys. I know you guys are excited and are trying to look for the zero on your dice, and there is none. So take a break and get a refresher, and we'll see you after the break. Bye. Welcome back, guys, to Maths Literacy Grade 11. Today we're doing probability. I know you guys have seen that it's pretty much an exciting show. So I hope you guys are ready for so much more. Remember, you can get hold of us on our Facebook page, facebook.com/LearnExtra, and our Twitter handle @LearnExtra. I'm looking forward to you guys' comments and questions and queries and motivational stuff. I like those stuff, so keep them coming through. Peter, over to you.
Right, great. So just before the break, we were looking at one dice, and Kat was trying to roll a 0, and she could never, ever get there. What we're going to do now is we're going to take it a step further, because you do need to understand, obviously you've done quite a bit of probability in grade 10, but it was just the very, very basic probability. Okay, so if I were to show you some very basic probability, let's have a look at what I'm going to do here now. Now, in the studio, I brought in some sweets. They're actually quite nice. They're called sugars. I love sugars, and I love it when my wife has one because it keeps her mouth going and I don't have to hear anything. So if I were to take the sugars out here, by the way, I do love my wife. I really do. I know some of you don't believe that when you hear me say these things, but they say you only tease those you love. All right, so I'll stop teasing her. Okay, now, if you look at the sugars, now what I'm going to do, I'm going to put them on the table here. I know you're not going to be able to see them very clearly, but you're just going to have to believe me and Kat, all right? And we'll tell you what color they are. So, looking over here now, I have some sugars. What color are those?
Those are green.
Those are green. Here's some more green. Here's another green. I've got a pink, another pink, another pink, and a yellow and a yellow.
Awesome, 3.
Okay, you happy with that?
Yeah.
All right. So let's get 15. So 1, 2, 3, 4, 1, 2, 3. That makes 7. Hey,
7,
cool.
sorry.
Okay, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we got one too many. All right. I'm going to show you a magic trick. I'm going to make this disappear.
Okay.
All right. You want to watch? Okay. Ready, steady. Okay, now it's all gone. So now what we're going to do is we're going to take these 15 sweets and we're going to put them inside a packet. Right. So I'm going to, oops, there's the green sweets. I'm going to put them inside a packet. Now I have brought a plastic packet to studio, mainly because so you can see what's going on. But Kat's not going to see what's going on because she's going to close her eyes. Now, if we had to look at this, what I'm going to do is write on the board here quickly how many green we had. So we had some green sweets, we had pink, and we had some yellow. Do you remember that? Okay, and how many yellow did we have? We had 3 yellow. And we had 4 pink, was it? Yeah, because that made the 7. And then we wanted 15, and so 15 minus 7 is 8. So we got 8 green. All right, now, Kat, if I had to say to you, because, sure, I learned that you get a lot of money for being here. All right, in fact, they've given you 3/4 of my money as well, but I don't hold any grudges. So if I had to say to you, right, you have to bet your entire salary, okay, on telling me what color we're going to pull out of this bag randomly, okay? Bearing in mind, we got 8 green, we got 4 pink, and 3 yellow.
Yes.
And you could only say, listen, Peter, if I choose a green, I'm going to win R1,000,000.
Yeah.
Okay? Or if I choose a pink, I win R1,000,000. Or if I choose a yellow, I win R1,000,000. What color would you go for?
Definitely green.
Why?
Because there's more of them. So
Absolutely. There are more greens. And because there are more greens, there's a greater probability that when Kat sticks her hand in here, she's going to pick a green. Okay. But there's still probability, there's still a chance that you could get a pink, that you could get a yellow. Agreed? Okay. So now I'm going to make life even more interesting for you. And I'm going to say, if you choose green, you win $1,000,000. Okay. If you don't take green, so if you take a pink or a yellow, I win the $1,000,000. Do you want to swap your color, or are you still happy with green?
I'm still happy with
You're
green.
still happy with green?
Yeah.
Absolutely. Why?
Yeah, because there's still more
There's
green.
8, and these two only make 7.
Seven.
But you wouldn't feel very comfortable. You'd be a
Yeah.
little nervous about it. Agreed? You'd be saying, oh my goodness, there's only one more green than
Then-
the other colors. Okay, so that would be slightly problematic. All right. Okay, so what we're going to do is we're going to do that.
Okay,
we're going
cool.
to choose a sweet out of the bag.
Can we make it R1 instead of 1 million rand?
We can make it R1.
Okay, awesome.
But first of all, I want to say, how many sweets do I have in the bag?
15.
15. 8, 12, and 3,
three.
15. So there's an 8 in 15 chance of me taking a green sweet. There's a 4 in 15 chance of it being a pink, and there's a 3 in 15 chance of it being a yellow.
Yellow.
Okay, so let's do this. So you're going to close your eyes, and you're going to choose a color. Now I'm doing this so you people can see, but she can't. Okay, only one, hey? All right, got it? And what you got?
Green!
A green,
Yay!
absolutely. Okay, and that's no surprise to me, folk, because we did expect a green to come up. Here it is, 8 out of 15 chances.
Yeah.
Okay, so Kat, my next question then is this. If I take this green sweet and I put it back in the bag, what is your chance of choosing a green sweet?
8 and 15
Still
again.
8 out of
Yeah.
15, would you agree? Why?
Yes.
Because there's still 8
yeah.
green sweets. There are still 4 pink and there's still
Still
3
4, yeah.
yellow. So I still have 15 sweets in total. Agreed? So let's do that again. All right. So walla, walla, walla. We do a bit of a handshake. She can't see. Let me open the bag. All right. You're in there. Cool. And without looking, she's chosen a pink. All right. Now, what were the chances of her choosing that pink color? There was a 4 in 15, but there was still the probability of her doing it. Okay, you happy with
Yes.
that? All right. Now, if I put the pink back, what would be the chance of you getting a pink?
Still 4 and 15.
Still 4 out of 15, but we're not going to.
Yeah.
Okay, we're going to throw the sweet away. All right. Now, my producer's moaning in my ear, hey, I'll eat that, don't throw it away. But you know what? She's eaten enough. So now the question is, how many pink sweets do I have left in my
3.
bag? 3,
Yeah.
absolutely. So what's the probability of me now getting a pink sweet?
3 and 15.
3 in 15. Absolutely wrong. There's 3 in 14 chances.
Oh,
Why? Because there are only
yes,
14 sweets left.
sweets.
Absolutely. So now we look at it and say, you know what? There's still 8 green sweets. But
Now there's 14.
he threw one away. So there's only 14. And I'm glad you made that mistake, because that's a kind of mistake so many students make in an exam. All right? Here, pink now, we've only got 3 left out of 14. And yellow, we got 3 left out of 14. Now, if I were to have said to you here, looking at this, what would you choose, pink or yellow? Which one would you have gone for?
If that one, the pink.
Just the
Still,
pink,
yeah.
agreed. Now I'm saying, look at this. Which one are you going to go for?
Any them, but the green obviously more. Because,
Okay, we're ignoring
but-
green.
yeah,
Just pink
but
or yellow?
Any of them.
It
They're
doesn't
the
matter.
same.
Hey,
Yeah.
why? Because there's an equal chance of her getting a pink or a yellow, because there are 3 of each.
Yeah.
Agreed? Okay. So, do we understand now what happens when we put something back in? The number still stays the same, and the probability remains the same. But soon as I start taking sweets out, then the probability begins to change.
Yeah.
And that's what we're going to do now, okay?
Okay.
You're going to take another sweet without looking, okay? And you're not putting it back. What color is it?
Green.
Green, fantastic. So now we're going to rub all this out, because these figures don't exist anymore. So now green, we're down to
7.
pink, we were down to 3, agree?
Yes.
All right. So what's the probability of getting a green? 7 out
and
of?
13 now.
Absolutely, because there are only 13
13
sweets
sweets.
left. Brilliant, hey? Sure, Ty could learn a thing or two from you. Okay, now, what's the probability of getting a pink? 3 out of 13 and 3 out of 13. Quickly, another sweet. By the way, you're going to eat these after the
Yeah,
show,
all
which
of
is
them.
absolutely fantastic. Okay, Green again.
Green again.
So now and can you see, we knew the chances of getting green are a lot higher because there's still more of them. So now what happens is I've now got 6 green, still 3 pink, still 3 yellow. So what we're now going to say is, well, okay, so I have 6 in how many chances?
Now.
12 chances, okay? 3 in, 12 chances. 3 in, 12 chances, okay? But now let's have a look at those figures. 6 over 12. Guys, if you had to simplify that down, 6 over 12 is 1 over 2. And your calculator can do that for you. Let me show you this. And guys, feel free to use your calculator in the exam. I always say to my guys, hey, if I see you doing maths without a calculator, well, that's just ugly, okay? It's like going for a swim without a costume. You just do not do that, okay? It's ugly. Right, so in the same way, if I've got a thing of 6 over 12, I'm going to push the fraction button, 6 over 12. Now watch what happens when I push the equal sign. Voila, 1 over 2. It simplifies it for you. You don't even have to think, okay? So what we're now going to do is say, well, that is actually 1 over 2 when we get a pen. Yeah, we got a pen. 1 over 2. What's 3 over 12? Well, let's make the calculator do the work. If we can get the calculator. Okay, so we're going to say, right, we've got 3 over 12 equals, now watch carefully, voila, 1 over 4. Okay, so it's now 1 over 4. Okay, 1 over 4 chances. 1 over 4 chances. Understand how this works? It's wonderful, hey? It's simple, simple, simple. What we're now going to do is we're going to play a game that I play with all my classes. And it's a game that I play with 2 dice. Right. So we finished with the sweets now. Okay. The producer will probably call a break because she'll want to run in and grab the sweets. She does it every show. It's so embarrassing. But what I've got now is I've got 2 dice. So we're now going to play with 2 dice. Do you remember we were playing with 1 at one stage? Okay, so now we're going to play with 2 dice. And what we're going to do, well, I'm not going to do it, you're going to do it.
Okay.
You are going to roll the dice, okay, and you're going to add up the figures. So if you roll a 1 and a 5, okay, so that's what we're going to do. So before the, during the break, I asked our producer, her name's Belinda, to choose numbers, and that's what she chose, 0, 1, and she chose 13 as well. And then she chose a 5. Kat chose 2, 3, and a 4. Also a 10, 11, 12. They only let me choose 3 numbers, a 6, a 7, and an 8. So it was very embarrassing. But being ladies, I let them go ahead and choose their numbers first, and they just got carried away and chose everything. So I've only got 3 numbers. You've got quite a few, and so has Belinda. Belinda said, by the way, she wants me to put a star next to her name. Absolutely. So we're going to do that because she is a disaster, and that's what we're going to do, all right? So there it is, a whole lot of stars next to her name just to show that it's Belinda and she's a disaster. And okay, right. So now what we're going to do is I'm going to give you the dice. Okay. You're going to roll them, you're going to add them. Yeah. Cool. Okay, all right. So you're going to do it quite quickly. You're just going to call out, and as you call it out, I'm going to tick. 5. 5. Okay, great. Well done, Belinda. She's got 1. Right, let's go. The first 1 to 10, by the way, wins the bag of sweets. Okay. Whoa. Right, let's go. Next one.
11.
11. Right, Kat, you on to some sweets. Let's go.
5 and 4, that's 9.
9, right. Our disaster is getting there. She's excited. I can hear her breathing heavily on the microphone. 10. 10 there for Kat. Well done. You're going. Let's keep going. Let's keep going.
3 and 2, 5.
5. Belinda there again. Oh, 8 away from a bag of sweets. Okay. 9. 9. Belinda again. Sure, she's getting there. And poor me is getting absolutely nowhere. All right. Okay. Roll the dice properly, woman. Let's go. Let's go. Let's go. Okay.
5.
5. Belinda's on her way to a bag of sweets. Okay. And
7.
Oh, at last I'm on the scoreboard. Right, let's go again.
3.
3. Right, Kat, you're on there. 8.
8.
Oh, well done. I'm back on the scoreboard. A 10. Okay, Kat, you're there. Everyone's doing well except me. 9. Belinda's going well. 11. Right. Roll the dice properly, lady. Okay, let's go.
9 again.
9 again. No, Belinda's breathing's getting rather heavy in my ear here on the microphone. Okay, 8. Well done. I'm on the scoreboard. Let's keep going. Okay, 7 again. Nice. Let's go. 8. Nice. Let's go.
Oh my goodness,
Oh
I'm
my
losing.
goodness, I'm getting excited
Okay,
here.
9
9,
again.
back to Belinda, rather disastering. Okay, let's go again. And 7, I'm back on the scoreboard. And we're going and we're going. And back to 5.
5.
Belinda's back there again. Okay. 6. Nice. 6 again, good stuff. 8.
8.
Okay, let's go. And 5. Oh, rather threatening there. 7 again. Right. And we got a 7 again. Oh, this is wonderful. Let's
These
keep
aren't
going.
being wrong.
The dice aren't working properly, are they? No, that's cheating. Roll it again. Check you women, I tell you what. 5. Belinda onto the scoreboard again. Let's go. We got a 7.
7.
Oh, I'm so excited. Here we go. And we got a 10.
10.
Kat, yes, well done. You're like 7 away from a bag of sweets.
Ooh, it's
Now
10
you're 6 away from a
again.
bag of sweets. And we got
10
10. Oh, no,
again. I
you just
promise
roll
you
those
I'm not
dice
cheating.
properly. I tell you what, eh? What women will do for a bag of sweets. 6.
6.
Okay, let's keep going. And 2. Ooh. Jeez. Okay. 7. Nice. And away we go. How far am I here? I'm nearly there, hey? 4. Right, Kat. Away you go. And 5. Cool. Belinda's getting there. And a 6. Nice. I'm there. And a
10.
10. Kat's on the scoreboard as well. And
a
9.
9.
Right, cool. And nice.
Another
9
9.
again for Belinda. Right, we're getting quite excited here.
And another 9.
And another 9. You really don't know how to roll the dice properly. Come on, come on, come on.
Roll.
A
And a
3.
3.
Okay.
Yeah. And 3
3
again.
again.
I promise you I'm rolling. And
9.
9.
Oh, no. How far is Belinda here? 1, 2, 3, 4, 5, 6, 7, 8, 9. You better not roll another 9. Okay, 12. Well done,
That's a
Kat.
new
Away you go.
number. And a 6.
Nice. Come, some 7s or 6s or 8s. A
And
9.
a 9.
Whoa.
Oh, no.
Our disaster of a producer
Yeah.
has just won the
Yeah.
game. You can stop rolling. She's got 10. 2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
That is just so sad. I mean,
She is a disaster.
it's for us, it's a disaster, I think. Okay. So why am I playing this game? Why did I do this? Okay. Here's the truth. The truth is that during the interval, I never let the ladies choose their numbers. I chose my numbers first. And the numbers I chose was 6, 7, and 8. Because if I had someone who knew how to roll the dice properly, I would have won this game. And I'm going to show you why I should have won this game. If we had played to 50,
Okay.
the chances are I would have won.
Yeah.
Okay? But we only played to 10 because otherwise we'd be here forever and our viewers would get bored and everyone would get bored and everything like that. So it's almost time for a break. Go away, get a glass of water and come back and I'll show you why I should have actually won this game. Keen?
Okay.
All right.
I really do think I should have won this game, but okay, you guys ponder on that for a little while. We'll see you after the break. Welcome back from your break, guys. Hope you guys got yourselves a bag of sweets because our producer took them all and I didn't even get one. So, hey, get me some sweets when you come by.
I know,
Peter.
did you hear that whoosh? I was
like
standing with the bag of
and the
sweets. It
bag-
was a
yeah.
thud roar
That's-
coming down the corridor.
That's all.
It
Not
was
even
like
one.
a whoosh, and the
And
bag
they were
was
gone. Even
Yeah.
the ones that Peter dropped on the floor.
Yeah, they were even
That
gone
one
as
was
well.
gone.
Oh, wait,
Oh,
they
there it is.
missed one.
Oh,
So
okay, there
we've
you
got
go.
one between. I'll give you half just now.
Yeah,
All right.
thank you.
Okay, cool.
Thank you.
All right, so why do you think I should have won? Why do you think I chose 6, 7, and 8? I'm going to show you. Okay. What happens if I roll a 1 and a 1? I'm going to get a total of 2.
So 2,
Agreed?
yes.
Okay, if I've got a pen. Right, there it is. A 2 plus 1 gives me 3.
3.
3 plus 1 gives me 4. 4 plus 1 gives me 5. 5 plus 1 gives me 6. And 6 plus 1 gives me 7. Okay? So let's go through. 2 and 1 is 3. 2 and 2 is 4. Is 5. Is 6. Oops, sorry. Is 6. Is 7. Is 8. Agreed? So we've got a 4 because 1 plus 3 is 4. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, and 12. Similar question was given in the last year's grade 12 IB paper, okay, where 2 dice were rolled. Now, how many possible outcomes are there if 2 dice are rolled? So 1 dice, I can roll it, and I've got a probability of actually rolling 6 numbers, or either a 1, a 2, a 3, a 4, a 5, or a 6. Okay? If I have 2 dice, how many possible outcomes are there?
Oh, lots. Double that. What you
Double
just
that.
said.
12, eh? Absolutely wrong. There are 36 probabilities.
I did say double.
Let me show you why, okay? Because, ignore that question, because I can have a 1 and a 2, a 1 and a 3, a 1 and a 4, 1 and a 5, 1 and a 6. I can even have a 1 and a 1. A 1 and a 1, a 1 and a 1, okay? If that dice is, first dice is 2, the second one can be
1.
A 1, a 2, a 3, a 4, that's a 2 by the way, a 5, or a 6. Can you see I've now already got 12 chances, okay? If I do it with 3, another 6, a 4, another 6. So the truth is I've got a probability of 36. And let's check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 6, and 6, and 6, and 6, 36. So there's 36 possible outcomes if I roll 2 dice. Got that? Now, why, or let me ask this, what's the possibility of taking 2 dice, rolling them, and getting a grand total of 0? Can you help me?
Sure, sorry, can you repeat?
Grand total of 0, rolling 2 dice?
No.
It's not going to happen.
Not going to happen at all.
It's not going to happen because you don't have a 0 on the dice. Okay? So do you remember earlier when, let's just see if it's on the next screen. Here we go. Do you remember Belinda, with enthusiasm, wanted the 0? Okay? Well, there was never, ever going to be a 0. It was never going to happen. What's the probability of taking 2 dice and rolling and getting a total of 1?
No.
Absolutely none. Because the minimum on 1 dice is a 1. My dice is gone. Here you are. Okay. The minimum on 1 dice is a 1. The minimum on another dice is also 1. And 1 and 1 is 2. So the least I can roll, if I'm adding the 2 dice, okay, or summing the dice, the dots on the dice, is 2. That's the minimum. So when Belinda proudly said, I'll take 0, okay, I proudly laughed and thought, oh, here we go. Okay, then she said, I'll also take 1. Felt a bit embarrassed that she was taking the lowest and said, okay, give me 13. Now, what's the highest we can roll on a dice?
12.
12. Because the highest I've got on 1 is 6. The highest I've got on the other 6. So the highest possibility is 12. So the probability of rolling a 0 or a 1 or a 13 is 0. It's not going to happen. So let's go back to our table over here. Okay? So the probability of rolling 0 is 0. The probability of rolling a 1 is 0. The probability of rolling 13 is 0. Not going to happen. So no matter how many times we roll that dice, Belinda was never ever going to get a tick next to her name where there was 0, 1, or 13. What's the probability of rolling a 2? Only 1, eh? One's got to be 1, the other one's got to be 1. So there's only 1 2. Can you see that? So the probability of rolling a 2 is only 1 out of 36 chances. The probability of rolling a 3 is 2 out of 36 chances. The probability of rolling a 4 is 1, 2, 3 out of 36. The probability of rolling a 5 is 1, 2, 3, 4 out of 36. The probability of rolling a 6 is 1, 2, 3, 4, 5 out of 36 chances. The probability of rolling a 7, now let's look at this, because this was going to be my moment of glory, and then Belinda messed it up for me, okay, is, here they go, all those sevens. 1, 2, 3, 4, 5, 6 out of 36 chances. 8, 5 out of 36, okay? The probability of choosing a 9, and this is where devastation hit me, because it shouldn't have happened, was 1, 2, 3, only 4 out of 36 chances. So let's say I brought someone into the studio who knew how to roll dice properly, okay? And they rolled the dice, I would have won. Why? Because I had the highest probability of winning, especially with number 7 here, okay? 9 only had 4 in 36 chances, but it was still pretty close. If you go back to our original table, if you look at a 2, even 12, what's the probability of rolling a 12?
1.
1 in 36. So if I go back to our table, and let's do that, okay, let's do that, there we go, all right. If we look at that, can you see 2 is very slim?
Yeah.
Because it's got the least probability chances of winning. Same with 12. We only rolled 12 once because it was only 1 in 36 chances of rolling that 12. But if you look at these guys, from number 5, and I'm going to take a different color. Let's go pink. No, someone took the pink off. Who does these things? Okay, let's use white. If you look at 5, 6, 7, 8, 9, they had the highest probability.
Yeah.
And look what happened, hey? Those are the numbers that actually came up the most. Right. And so, if I had drawn this on a, if I'd drawn this, and if it was done properly, and if I had someone in the studio who could really, really roll a dice, maybe you viewers out there know how to roll dice properly. Write us a little message. Say, hey, kick off the show. Put me on. I'll make your figures work out properly. Okay. What would have actually happened was we would have got something like that happening. Can you see? With most of the chances coming out the 7. And I can almost guarantee in my classroom I've got a simulator dice, which means I've got a dice on a computer. And I can say roll the dice 1,000 times, and I push a button, and it rolls the dice 1,000 times. But it all does it in a matter of seconds. Hey, we're talking like 5 seconds as rolled it 1,000 times. And it gives this perfect shape. It shows how many times 7 has come up. And it always works out like it. If I only had to roll it once, okay, then the chances of me winning still high, but not as great as rolling it 100 times or 1,000 times or whatever the case is. Are we clear on that?
Yeah, we are.
Okay. Are we happy with all this?
Yes.
Right. Now, let's go back to look at a question. Right. No, let's go forward to look at a question. Right, here. 2 dice are rolled. What's the probability of rolling 2 4s? What's the probability of rolling 3 5s? What's the probability of rolling 2 even numbers? So first thing, what's the probability of rolling 2 4s? And I'm going to look at this that I've drawn here, okay? 2 4s. In other words, a 4 and a 4. What's the probability of that happening? Only once, okay? So I'm taking my dice. I've got to land up with a 4 and a 4, okay? It can only happen once. And how many probabilities are there? There are 36. So the probability of rolling a 4 and a 4 or 2 4s is 1 in 36 chances. What's the probability of rolling 3 5s? So I've got 2 dice and I want to roll 3 5s. Guys, that's not going to happen.
Never going to happen.
Okay? Why is it not going to happen? Because I've only got a possibility of 2 5s. Here they are. Okay, here's a 5, and here's a 5. Let's freak out the producer. Here they are, okay? 2 5s. That's all I've got. I don't have a third dice, okay? So the probability of rolling 3 5s is 0. What's the probability of rolling 2 even numbers? Let's go back and look here, okay? Let's try go back and look here. Okay, here we go. So 2 even numbers, right? So 2 even numbers, there are the same amount of odd numbers as what there are even numbers. Okay? So rolling 2 even numbers and 2 odd numbers, I've got exactly a 50% chance. Or do I?
50.
No, I don't.
No, you
Why
don't.
not? Because I could roll an odd and an even.
Oh, yes. And you could roll
I could roll an odd and an odd. and I could roll a even and an odd.
Yeah.
So if I went back now and I made life very miserable for myself and I drew all this up, okay, I would say chance of rolling 2 even numbers is not going to happen there.
There, yeah.
Okay? The chance of it happening here is there, there, and there. So there are 3 chances. If I looked at my 3s, it's not going to happen if the first dice is a 3. If I looked at 4, 4, 2, 4, 4, 4, 6, 3 chances. Okay? Here it's not going to
Not
happen.
gonna happen.
If I looked at 5, not going to happen. 6, I could get 6, 2,
3
so I've
again.
got another 3. So I've got 3, 6, 9 in 36 chances of it actually happening. Now, 9 in 36 is going to be a quarter. 1 in 4 chances of that actually happening.
Awesome.
All right. This is fantastic. We're going to carry on next week with
Yeah,
it.
let's do it next week, guys.
Cool.
We had a great show. Thank you, Peter. Thank you, Mindsetters. I know you guys were awesome and you guys want our sweets, but no. Enjoy your week, guys. See you next week. Bye.